Hi, good day everyone. So for today, we're going to learn more about chemistry and I hope you enjoy learning and you learn something about the video. Hello everyone. Today, we'll be going to discuss about chemical kinetics, specifically on how to determine a root law using an experimental data. At the end of the lesson, students should be able to write a root law using an experimental data, find and determine the root constant K of the reaction and its units. Determine the order with respect to each of the reactants present in the root law. Determine the overall order of the reaction. And find the root of the reaction. But before that, let us talk about root law. Root law is a mathematical relationship obtained by comparing reaction rates with reactant concentrations. The reaction order is the sum of the concentration term exponents in a root law equation. A reaction's law may be determined by initial roots method. A general formula in writing a root law is negative R equals to K times the concentrations of A and B raised to M and N, where M and N are the order of each reactants, K, the root constant, and the bracket represents the concentration of each reactant present in the equation. So for this time, we have here two reactants, A and B, and R is the root of the reaction. So we can only use this one if our equation is just like this. A plus B gives C. Or we can read this as A reacts with B to form a C. So how about the root constant? So for this lesson, we'll use letter K or the small k to represent the root constant. So the root constant or the specific root constant is proportionality constant in the equation that expresses the relationship between the root of a chemical reaction and the concentrations of the reactant substances. The units of the root constant K depend on the overall reaction order. In determining the units of the root constant, use M raised to the quantity of 1 minus n over S, where M refers to the molarity or the moles absolute per liter solution and S refers to second or time. So let's proceed with our problem. The initial rate of a reaction A plus B gives C was measured for several different starting concentrations of A and B, and the results are as follows. So we are given with table containing results of experimentation. So using this data, determine A, root law for the reaction, B, the root constant K, C, the reaction order with respect to A and B, D, the overall reaction, and the rate of the reaction when concentration of is equal to 0.050 m and the concentration of B is equal to 0.100 m. And we are given with the reaction of A and B to convert C. And also our experimental data. And we are asked to find the following. First, rate law for the reactants. So since we are given with two reactants, we can write our rate law equation as negative R equals to K times the concentration of A raised to M and the concentration of B raised to N. So please take note that the negative sign convention for R means only that the reactant is being consumed in the reaction. And the next one is to find the rate constant K. Next, the reaction order with respect to A and B. Next, overall order reaction. And the rate of reaction when concentration of A is equal to 0.050 m and concentration of B is equal to 0.100 m. So let's now proceed with our solution. So first, solve for the reaction rate. So negative R equals to K times the quantity of A raised to M, B raised to N, where M and N represents the order of each reactant. And next, solve the value of M by writing the rate law equations. Negative R equals to K times the quantity of A raised to M times the quantity of B raised to N by substituting those values found on the table using the data from trial numbers 1 and 3 respectively. So from the table, we have obtained our values. So for trial number 1, we'll have negative R equals to 4.0 times 10 to the negative 5, and the concentration of A is equal to 0.100 and concentration of B is equal to 0.100. Then we can also substitute these values from the given formula. So as stated above. And then we can say that 4.0 times 10 to the negative 5 is equal to K times the quantity of 0.100 raised to M times the quantity of 0.100 raised to N. So we can set it as equation number 1. So the next step, for trial number 3, we'll have negative R is equal to 16.0 times 10 to the negative 5. Concentration of A is equal to 0.200. Concentration of B is equal to 0.100. Then we can substitute these values from the given formula. And then we can say that 16.0 times 10 to the negative 5 is equal to K times the quantity of 0.200 raised to M times the quantity of 0.100 raised to N, and we can set it as equation 2. Divide equation 2 by equation 1, we can obtain this answer. And then after that, we'll have to cancel all the common values or units. So for this time, we can get the answer of 16.0 times 10 to the negative 5 divided by 4.0 times 10 to the negative 5 equals to 0.200 raised to M divided by 0.100 raised to M or 16.0 times 10 to the negative 5 divided by 4.0 times 10 to the negative 5 equals to the quantity of 0.200 divided by 0.100 raised to m. And after performing division operation, we can get 4 equals 2 raised to m. And from there, we can get our value for m equals to 2. So we'll have already obtained the value of m, which is equal to 2. So next, solve for n by using data from trial numbers 1 and 2. For trial numbers 1 and 2, we can obtain the following data. Negative r equals 4.0 times 10 to the negative 5. The concentrations of A and B, 0.100. And for trial number 2, negative r is equal to 4.0 times 10 to the negative 5. Concentrations of A and B, 0.100 and 0.200 respectively. Then we can obtain the following equations for trial numbers 1 and 2 as follows. So 4.0 times 10 to the negative 5 equals K times the quantity of 0.100 raised to m times the quantity of 0.100 raised to n, and 4.0 times 10 to the negative 5 equals to K times the quantity of 0.100 raised to m times the quantity of 0.200 raised to n respectively. And set 4.0 times 10 to the negative 5 equals to K raised to 0.100 raised to m times the quantity of 0.100 raised to n as equation 3. And also set 4.0 times 10 to the negative 5 equals to K times 0.100 raised to m times the quantity of 0.200 raised to n as equation. And after that, divide equation 4 by equation 3. So we can obtain these equations as being presented in the slides. And after that, cancel all the same values. So we can obtain an answer of 1 is equal to 0.200 raised to n divided by 0.100 raised to n, or 1 is equal to the quantity of 0.200 over 0.100 raised to n, or 1 is equal to the quantity of 2 raised to n. So for this time, in order to have an answer of 1, so we need to raise the number to 0. So n is equal to 0. So our answer for letter A is reaction rate is negative r, or reaction law. Negative r is equal to K raised to the concentration of A raised to 2 times the quantity of B raised to 0, or negative r is equal to K times the quantity of A raised to 2. And for this answer, the exponents here, 2 and 0, represents the order of reactants A and B. So for our next step, solve for the rate constant K by substituting all the values into the formula given. So using data of any of the trial number, so remember the general formula in getting the units of K is m is the quantity of m raised to 1 minus A over s raised to 1. So for this discussion, we'll use L, but on different books they'll use N to represent the number of the order of reaction with respect to or the overall reaction, where M refers to the molarity, the overall order of the reaction, and S is the second or the time. Let's use this and substitute all the values from trial number 1 in the formula given. So we'll have negative R equals to 4.0 times 10 to the negative 5. The concentration of L is equal to 0.100. B is equal to 0.100 also. So by substituting these values, we can get the following as presented. So for B, we can obtain our answer as 4.0 times 10 to the negative 3 per molar per second. So for letter C, the reaction order with respect to reactant A is represented by small m, which is equal to 2, and for reactant B is represented by small n, which is equal to 0. Then for overall reaction, get the sum of values represented by m and n respectively. So 2 plus 0 is equal to 2. So the overall order of the reaction is 2, or we can say that the overall order of the reaction is in second order.